Every year, about 3,000 to 3,500 tons of gold are extracted worldwide. Just the global central banks hold more than 36,000 tons of this precious metal in their reserves. With the market valued at over $15 trillion, gold is the most important asset on the planet. But do you know how gold bars are made? Discover now the complete industrial process that transforms raw gold into pure, certified bars that guarantee the wealth of nations. It all starts long before the gold reaches a refinery. The first step is searching for gold deposits in nature. Geologists and researchers use a combination of geological knowledge, topography, and advanced technology to identify areas with potential. This can involve anything from soil and rock analysis to the use of satellite images and geophysical mapping. Once a promising area is identified, exploration begins, which involves drilling samples to determine the concentration of gold and the economic viability of the mine. There are different types of gold deposits. Some are found in quartz veins within hard rocks, requiring underground mining. Others are scattered in alluvial deposits, such as ancient riverbeds, which allows for open-pit mining. The choice of mining method depends on the nature of the deposit and its depth. In underground mining, tunnels and shafts are excavated to reach the gold veins. It is challenging and dangerous work that requires heavy equipment and specialized labor. The rocks containing gold are broken up with explosives and then transported to the surface. In open-pit mining, large areas are removed to expose the ore. This usually involves creating large holes and using giant trucks and excavators to move tons of earth and rock. Regardless of the method of excavators to move tons of earth and rock, the underground mining method is the same, to extract the rock that contains the gold. This rock still doesn't look anything like the shiny bars we know. It is a mixture of gold with other minerals and impurities. Once extracted, the ore needs to go through a process called beneficiation. The goal here is to concentrate the gold, separating it from most of the rock and from unwanted minerals. The first step is crushing, where the rocks are reduced to smaller pieces in giant crushers. Next, these stones are ground in mills that turn them into a fine powder, almost like sand, to make it easier to release the gold particles. After grinding, the most common method to separate the gold is flotation. In this process, the ground ore is mixed with water and special chemicals in large tanks. Air bubbles are injected into the mixture, and the gold particles, which are hydrophobic, do not mix easily with water. They stick to these bubbles and rise to the surface, forming a gold-rich froth called concentrate. The rest of the rock, which is hydrophilic, sinks to the bottom of the tank. The froth is then collected and sent to the next stage. Another widely used method, especially for low-grade ores, is cyanide leaching. The ore powder is placed in large heaps or tanks and treated with a diluted cyanide solution. After beneficiation, the gold is still not pure enough to be turned into high-quality bars. The refining stage is crucial to achieve the desired purity, which is usually 99.9%. There are two main refining methods: electrolytic refining and Miller refining. Electrolytic refining, also known as the Wohlwill process, is an electrochemical method. Impure gold in the form of an anode is submerged in a gold chloride solution. A pure gold cathode is placed in the same solution. When an electric current is applied, the impure gold from the anode dissolves into the solution and then deposits onto the cathode as high-purity gold. The Miller process is a pyrometallurgical method that uses high temperatures. The impure gold is melted in a furnace, and chlorine gas is injected through the liquid metal. The chlorine reacts with the metallic impurities, forming chlorides that are volatile or create a slag on the surface of the molten gold. These chlorides and slags are removed, leaving behind pure gold. The Miller process is faster than electrolysis, but it usually produces gold with slightly lower purity. Many refineries use a combination of both methods, starting with the Miller process and then further refining with electrolysis to achieve maximum purity. With the gold already refined and at its maximum purity, It's time to turn it into the bars we know. This step involves precision and control to ensure that the bars have the correct weight and dimensions. The purified gold is melted again in a furnace, reaching temperatures above 1,000 degrees Celsius. The liquid metal is then carefully poured into molds. There are two main casting methods: casting by pouring and continuous casting. In pouring casting, the liquid gold is poured manually or by an automated system into preheated molds, which can be made of graphite or cast iron. Each mold is designed to produce a bar of specific weight and dimensions, such as 1 kilogram, 100 G, or even larger bars of 12.5 kilograms, the famous good delivery bars used in bullion markets. After pouring, the gold cools and solidifies inside the mold. Once solidified, the bar is removed. In continuous casting, the liquid gold is poured into a system that solidifies the metal into a continuous strip. This strip is then cut into specific lengths to form the bars. This method is more efficient for mass production and allows for more precise control of the shape and size of the bars. After casting, the bars are visually inspected to check for the absence of imperfections, air bubbles, or cracks. Next, they undergo strict weighing and measuring processes to ensure they meet international standards. High-precision scales are used to determine the exact weight of each bar. Once the gold bar is cast and weighed, it still needs to receive its identity. Marking is a crucial step that gives authenticity and traceability to the bar. Each investment gold bar carries essential information engraved on its surface. This includes the weight of the bar, indicated in grams, ounces, or kilos, the purity level, and the name or logo of the refinery, which certifies the origin and quality of the bar, and a unique serial number, which allows the bar to be tracked from its production to its eventual sale. After marking, the bars may undergo a finishing process. Although some refineries prefer to leave the surface of the bars with a more rustic and natural casting appearance, others subject them to gentle polishing to enhance their shine and aesthetics. And that was today's video. Remember to like and subscribe to the channel.